Hello. My name is Mark Dörr. I'm from Greifswald University, and I would like to present our LARA suite here. The LARA suite is a very, very challenging project. So it's about fully automating the whole research process in life science. So it's not about only catalysis. So it covers, so it's designed for all experimental scientists, scientific experimentations projects. So that's crazy. It sounds crazy. It is crazy. But I will try to explain to you how the architecture looks like and what we try to achieve and how we do it. And the most important thing that you should understand with this project is that we try to automate as much as possible. So the future of laboratory investigations is automation. So in the future, you will not be there putting stuff together. So I'm already in contact with these cloud labs, huge robotic facilities in the US that have instrumentation of the size of this hall here with a lot of robots just doing what you submit. So you have a submission system, you submit a workflow, and then the cloud labs operate. And we have a similar lab, but much smaller. So I can really talk about automation out of all my own experience. So we try to make a research data management system fully maximized, automated. And how this looks like, so the architecture of this is that you as a scientist, so what we want is that our research is really focusing on the science itself. So like Norbert was here. Yeah, so Norbert was in this workshop talking about that we should really focus as scientists on our scientific work, on all these gears that should work behind the scenes. They should just work. It's the machinery that we build up. It should be opaque to the scientists, and this is how we try to do it. So the planning of an experiment, this is something that all of us need to do, and there's no automation about it. So this is something we can't automate. But then, once you have decided about the processes, the substances you want to use, the organisms you want to use, the devices you want to use, then we can submit such a design of an experiment to an orchestrator, and we have a process description language that executes, that formulates what the orchestrator should do. And then this orchestrator uses, so that's another very important part of this LARA suite. We're using standardized protocols for everything, standardized data formats. So we are using the SILA standard, which stands for Standardization and Lab Automation, and it's an open source standard worldwide developed by a large community, and more and more devices nowadays become the SILA standard. So once you have a device operating SILA, you can directly plug it in and run it. So that's very impressive. And if you don't have a device like a thermometer that you just have for a long time that is not adhering the SILA standard, it's very simple to make a SILA device out of it. It's extremely simple. So we can then address very simple devices like thermometers, but also complex things like reactors or even like our robots. But not only that, but you can also address machine learning algorithms and humans. So you can integrate the human in the workflow, and it can tell now do this step. And then we have like a standardized, again, using standardized protocols to collect all the data that is generated by this and put it into a database. And here comes the importance of this relation between structured data, tabular data, and semantic information. And since this is so different, we have two storages. So one storage for tabular data, like huge substance database of millions of substances, reactions, organisms, and whatever. And then we have a triple store And this triple store stores more the semantic information, the ontology-based information that you can then query with SparkQL. And but what we don't want is to generate silos. So we also have a company now engaged that helps us to write the synchronization parts. So we can run multiple instances of this LARA suite at universities, in your own institution, so every institution can have one, and then you can synchronize between them or between large institutions. And what we are also do is like writing a connector to Zenodo and to the Dataverse and other repositories to make it as simple as possible to submit then the data in the end to these higher repositories finalized for publication. That you don't need to enter all this meta information again and again by hand. That's the most important thing. That's once stored in this system, automatically enriched by the process of metadata enrichment, automated metadata enrichment in ontologies, and then you have the data already ready as much as possible. So that's the overall goal of this project.
Thank you so much, Mark. I really like the presentation. Is there any questions for Mark? Norbert.
Close to the microphone. Yeah, thank you very much for this overview. And now I understand a little bit more. You were talking about Sila and animal and that stuff. Yeah. You started with the experimental planning and said that is human input, no automation. Is there any possibility to, from the queries, getting some starting point, some assistance?
Sorry, of course. I mean, it's once you specified an experiment and you have this formalism, one of the ideas is to make feedback loops. Yeah. And something like a machine-guided experimentation. And since you have all these years, so we have a description language that is formalized, highly formalized, that is standardized, and you have all the automation, communication infrastructure, you can in the end make like this robot scientist experimentation. So Ross King's kind of type of experiments with that, very general, accessible. So you need don't need like a special software. So it's all it's doable in this framework, which is open source, by the way, and publicly available, and it's very simple to install. So it's just 2 commands. It's Dockerized, and it's running on a Docker infrastructure. I have a Docker image. If you want to test it, you can. I have an instruction how to download its 2 commands, and then you have a large, very complex thing.
Thank you so much. Yeah. You have another question?
Yeah, thanks for the presentation. I have a question concerning the coupling with Sila as well.
Yeah.
So for example, we have mainly LabVIEW as controlling software for our reactors. Other people may have Haiteng Sang or there are different tools available people use. Is there an answer or is there a way for your software to combine this as well, or should one move to Sila to use it? Or
well, so the way how it's right now organized is that it's very, very flexible what you communicate. So you can also use OPC UA as another standard, which is more common in your field. Or, I mean, if you have like a proprietary protocol, it's not a big problem to edit because all the communication modules are modular. So you can just add then a proprietary protocol and then communicate with that. So you just need to adhere a certain standard in the way how you formulate how you abstract your device. So you need to have a certain device abstraction, like balance can be abstracted by the functionalities like Tara, Way, etc. If you have such